Hey everyone, welcome. This is section 4.4 and we're talking about triangle congruence shortcuts. So today we're going to look at these three triangle congruent shortcuts, or I'll say potential triangle congruent shortcuts, because we're going to sort of investigate which of these three work. And when I say work, I mean they prove to us, or they show us, that the triangles are congruent. So the first one on the left here is side, side, side. And what this says is that if the three sides of one triangle are congruent to three sides of another triangle, does that mean that the triangles are congruent? The one in the middle here, side angle side, notice that we have two sides congruent, and we have an included angle that's congruent. That included angle is between the two congruent sides. Is that enough information to determine the two triangles are congruent? And then we have side-side angle. So again, we have two sides, two pairs of congruent sides, and we have a congruent angle. But now that angle is not an included angle. It's not between the two congruent sides. It's a different angle. Is that enough information to determine the two triangles are congruent? Well, let's take a look. Before we get into the investigations, I want to clarify this understanding of an included angle and an included side. You'll see that in the diagrams, the included angle is the angle between two sides of a triangle. Now you might be saying, well, every angle is between two sides of a triangle. But an included angle is between two identified sides of a triangle. So in our diagram here, you can see that we've identified these two sides with these congruency marks. And so the included angle, if those are the two sides we're working with, would be this angle, right? The other two angles, here and here, would be the non-included angles. Same thing with an included side, right? Well, every side is between two angles, but if we identify two angles, then the included side is the one in between those two angles, and you can see it labeled in that diagram. And this is going to be important moving forward to distinguish between some of the triangle congruency shortcuts. All right, so we're going to investigate the side, side, side congruent shortcut, right? We're going to see if this is actually a shortcut. So let me pull up my compass. And what I'm going to do is I am being given three segments, AC, BC, and AB. And I'm going to construct a triangle with these three segments. So let me start with a ray. And I'm going to duplicate AB on that ray. So let me take my compass, bring it up here, set that there. And I'll extend this, just long enough. Look at that. So I'm going to rotate this around, put it on the end point. It looks pretty good. And I'm going to strike an arc. So right there. So there's the length of AB. Now, let me come up here. Let me measure BC. Okay, BC. I'm going to put my compass on this end point again. And I'm going to strike a nice big arc BC, because next I'm going to measure AC. I'm going to come down here. Let me rotate this around. Put my compass on that end point. And now I'm interested in where these arcs intersect, right? So what I have is, this was A, B, and then this was AC would go from here to here, and BC would go from here to here. So now I've constructed triangle ABC. Now the question that I have to ask myself is, with these three given segments, could I construct a triangle that is different from this triangle? Because if I could, then that means that having three congruent sides is not enough information to conclude that the triangles are congruent. If I can't, which in this case I can't, right? If I change an angle of this triangle, that's going to change the side lengths. So given the three side lengths that I've been given, this is the only triangle that I can construct, which means if I have two triangles and the three sides of one triangle are congruent to the three sides of the other triangle, then I have enough information to conclude that the triangles are congruent. All right, so now we're going to look at the side angle side congruent shortcut. And remember that the angle is an included angle. It's in between the two sides. And you can see that from the name, right? SAS, the A for angle, is between the two sides. So that's helpful. There's our ray. And let's construct. So I'm going to duplicate angle D on this ray. Whoops. I'm going to come over here, put that there, and measure out to the arc. Bring this down here. This is a good review of constructions as well. And I'm going to strike that arc. Then I come back over. That looks pretty good. I'm going to come over here, put my compass there, and going to strike that arc. Now I can draw in second ray of angle D. So I know that this is D. Now let me measure DF with my compass. There we go. And it doesn't matter where F goes, which ray it goes on. So I'm going to strike that arc. So this is F. And then let me measure DE. Put my compass on point D and strike an arc there. So now this is E, and I can finish my triangle by connecting F and E. Now again, the question we have to ask is, given two sides, DE and DF, and the included angle, in this case D, could I construct a triangle different than this triangle? And the answer here is no. There's no way that I could do that. If I change the length of DE, that's going to change the length of FE. If I change the length of DF, that's going to change the length of FE. It's going to also change some angles. So I wouldn't have the same parts. I wouldn't have the same parts up here that I started with, right? So given these parts, this is the only triangle that I can construct. Therefore, we conclude that having two sets of congruent sides and the included congruent angle is enough information to conclude that two triangles are congruent. All right, so last one, side-side angle. So we have two sides and one angle, but it's not an included angle anymore. So let's do the same thing. Let's construct a triangle. Start with my ray, and let's duplicate angle S. So take my compass, and rotate this around, bring it up here, put it on vertex S, measure out to this arc. Right there looks pretty good. All right, bring it back over here. Oh. Strike my arc, come back over. Measure this opening. Looks pretty good. Come over. Put my compass there. Strike that arc. So there's angle S, so I know that this is point S. Now let me measure ST, since I have point S. So take my compass, measure ST. Okay, looks pretty good. Bring that down here, and let me flip this around. Put this on S. Strike that arc. So now I know that this is point T, ST. Okay, now I can duplicate TU. So let me come over here and measure TU. Got it. Come down here. Put my compass on T. Looks pretty good. And now strike an arc. Now, this is interesting, right? Now that arc, notice how it kind of crosses over that line, doesn't it? So where it really intersects that other line or ray looks to be about right there, but then it also intersects it right there, doesn't it? It intersects it at 2 points. So what this means is I actually could come up with two different triangles. I could come up with a triangle that went from T to this point, or I could come up with a triangle that went from T to this point. Those are two different triangles. And this is the first time that we're seeing this. In the two previous investigations, the parts that were given to us resulted in one triangle that could be constructed. But now in this investigation, the parts that are being given to us result in two different triangles being constructed. So this is the first instance where we see the pieces that are given to us, the two sides and the non-included angle, are not enough information for us to conclude that the two triangles would be congruent. So what we conclude here is that side, side, side is a congruent shortcut, side, angle, side is a congruent shortcut, but side, side, angle is not a congruent shortcut. And we'll take a look in class tomorrow at problems where we apply these triangle congruent shortcuts.